For today's video, we'll be using mathematical induction to prove that 2 plus 4 plus 6 plus 8 plus 3n minus n is equal to n times n plus 1. The first thing we'll need to do is the basic step. Show that P1 is true. And to do that, we will let n be equals to 1. That's right. 2 is equal to n times n plus 1. Substitute, we have 2 equals to 1 times 1 plus 1. 2 equals 1 times 2. 2 is equal to 2. Which means the statement is true. Now, let's move along. Next thing we need to do now is the inductive step. Okay. Let's assume that n is equal to k. Now, let us assume that the formula holds for positive integer k, that is 2 plus 4 plus 6 plus 8 plus 10. 8 plus 3k minus k is equal to k times k plus 1. Then show that it holds for positive integer k plus 1. That is 2 plus 4 plus 6 plus 8 plus 3k minus k plus 3k plus 1 minus k plus 1 is equal to k plus 1 times k plus 1 plus 1. And that's equal to k squared plus 3k plus 2. And now, we'll have to prove that this statement is true. Here is our proof. Let's write 2 plus 4 plus 6 plus 8 plus 3 k minus k plus 3 times k plus 1 minus k plus 1 is equal to k plus 1 times k plus 1 plus 1. Now, let's combine terms and distribute and FOIL. So we'll just rewrite this. Just copy and paste. 2 plus 4 plus 6 plus 8 plus 3k minus k plus 3k plus 1 minus k plus 1, and solve for this one, and we'll get k squared plus k plus k plus k plus 1 plus 1, and we'll get k squared plus 3k plus 1. So we can conclude that the formula holds true for all positive integers. That is all. Thank you.